The star insect Jew, a red, exceptionally huge beast tracked down in the brilliant group of Orion, has long enchanted stargazers and cosmologists alike in light of its sheer size and brilliance. If Betelgeuse were put where our Sun is, it would reach out to the orbit of Jupiter, certifying its Goliath size. Notwithstanding being situated around 642 light-years from Earth, its immense size makes it perhaps one of the most brilliant stars visible to the unaided eye. Also, at any rate, actually, insect Jews has shown strange behavior, such as astonishing obscuring and illuminating cycles, which numerous specialists believe signal that the star is moving toward the finish of its life. The popular physicist Brian Cox recently offered a simple statement that Betelgeuse is on the edge of a staggering impact expected to happen within the next 14 days. This event, known as a cosmic explosion, will mark the finish of Scarab Jew's life. In any case, it will provide a dramatic opportunity for specialists to study one of the most astounding and strong phenomena in the universe. As a red supergiant, Betelgeuse is named one of the largest and most enormous types of stars. It has been on the galactic radar for a long time, yet its new, flighty fluctuations in brilliance have sparked theories that it is preparing for a cosmic explosion. When a star like Betelgeuse reaches the end of its life, its center collapses under its own gravity, triggering an enormous blast that releases a tremendous amount of energy, radiation, and inestimable material into space. Betelgeuse's oncoming impact is expected to be a Type II cosmic explosion, an explicit sort of divine blast that happens when the core of a large star falls. This core breakdown triggers the release of neutrinos and radiation, creating a shock wave that destroys the star. The blast will be so brilliant that it could be visible from Earth without telescopes, potentially even eclipsing the moon in the night sky for weeks or months. While such an event would typically be horrendous if it occurred near Earth, Betelgeuse's distance of around 642 light-years actually means that although the impact will be apparent and dramatic, it won't present any risk to life on our planet. Nonetheless, the event promises to reshape how we understand supernovae and large phenomena. A cosmic explosion is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will emit throughout its entire lifetime. Scarab Jew's impact won't just be an extraordinary vast display but also a huge moment for science. Scientists are eager to observe this interesting event from its earliest moments, utilizing a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse detonates, it will emit a wide range of radiation, from visible light to gamma rays. One of the most significant aspects of the cosmic explosion will be the surge of neutrinos, elusive subatomic particles that seldom interact with matter. Neutrinos from a cosmic explosion can actually reach Earth before the light from the blast because of their ability to pass through almost everything without being affected. Observatories like Japan's Super-Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving an early advantage in tracking Betelgeuse's final moments. Betelgeuse's eventual explosion will likely ignite a renewed interest in space exploration and the search for habitable planets as we continue to look for Earth-like planets in the habitable zone of other stars. Understanding the processes that govern stellar evolution is key to identifying planets capable of supporting life. The more we learn about the life cycles of stars, especially those similar to our own Sun, the better we will be able to assess the potential for life beyond Earth. The scientific community is anxiously preparing for Betelgeuse's imminent demise, not only to observe the explosion itself but also to study the aftermath. The remaining core of the star will either collapse into a neutron star or, depending on the mass of the remaining core, a black hole. This will create a celestial remnant that could emit a range of energetic emissions, providing further exciting opportunities for studying Betelgeuse's supernova. Betelgeuse's explosion is expected to leave behind a rich legacy of data and discoveries, shedding light on some of the deepest mysteries of the universe. As astronomers continue to monitor Betelgeuse, their hopes are growing. The star's variability has sparked intense scientific interest, and while no one can predict exactly when the supernova will occur, the whole world will be watching. This giant star's dramatic end, whether observed through telescopes or simply as an awe-inspiring astronomical spectacle, will be a remarkable event, offering both scientific insights and a poignant reminder of the eternal cycle of life and death that shapes the universe. The blast will also provide vital insights into the formation of heavy elements. When stars explode, they produce and disperse elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's cosmic explosion will offer specialists a clearer view of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's cosmic explosion isn't expected to have a catastrophic effect on Earth, it will interact with our planet's climate and magnetic field in fascinating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the areas where the northern and southern lights are visible. While these vast rays could affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and brief. Perhaps one of the most exciting aspects of Betelgeuse's impact is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will captivate not only professional astronomers but also amateur astronomers and the general public, reigniting interest in space science and the universe. Scientists have long theorized about Scarab Jew's death, but Brian Cox's recent statement adds urgency to the situation. Observatories worldwide are preparing to monitor each stage of the cosmic explosion, and the data gathered will be crucial, potentially changing our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's cosmic explosion will allow analysts to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such a blast travels through space by observing the light and radiation from the explosion as it interacts with the interstellar medium, the gas and dust between stars. Cosmologists will gain a clearer understanding of the size of the universe. The event will also offer a once-in-a-lifetime chance to study dark matter and how it may impact the structure of the universe. By studying Betelgeuse, researchers will gain valuable insights into how these elements are created and distributed. The cultural significance of Betelgeuse's blast is also important. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most visible stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such divine events have been interpreted as signs or symbols of monumental change. Betelgeuse's impact might inspire a blend of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and astronomy, bringing more people into the quest for knowledge about the universe. Amateur space experts are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the cosmic explosion. This democratization of science will unite people across the globe, all watching and recording the same monumental phenomenon from their unique vantage points. Scarab Jew's explosion isn't just a magnificent celestial event but also a stepping stone for future exploration. The data collected from the cosmic explosion will inform how we study other stars, especially as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is critical as humanity looks to extend its presence in the nearby solar system and beyond. Furthermore, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are crucial for spreading the building blocks of life, like carbon and oxygen, across the universe. By studying Betelgeuse's blast, scientists can better understand how the building blocks of life could spread to other planetary systems and potentially spark life elsewhere in the universe. The looming blast of Betelgeuse is set to be one of the most significant astronomical events in recent memory. Its cosmic explosion will provide a wealth of scientific data, enhance our understanding of the universe, and undoubtedly captivate people around the world. Scarab Jew's death will mark the end of a giant star. However, it will also symbolize the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this memorable event, the world will anxiously watch the night sky, anticipating the moment when one of the universe's most powerful forces explodes into view. For both scientists and stargazers alike, Betelgeuse's final process will be extraordinary. As Betelgeuse approaches the last phase of its life, one of the more speculative yet intriguing possible outcomes connected with its impending blast is shedding light on some of the universe's greatest mysteries: dark matter and dark energy. These mysterious forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some hypothesize that supernovae, like the one predicted from Betelgeuse, could hold the key to unlocking some of these mysteries. Supernovae release tremendous amounts of energy and radiation, and some scientists believe these powerful forces might interact with dark matter in ways we can observe and study. One intriguing hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy produced by Betelgeuse's cosmic explosion could provide clues to their nature. Such a discovery would offer the first direct proof of dark matter, a mysterious phenomenon that has baffled scientists for decades. Moreover, there is potential for Betelgeuse's explosion to offer insights into the nature of dark energy. Dark energy is the strange force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the biggest challenges in current physics. Betelgeuse's blast could provide indirect evidence of dark energy's impact on stellar death, as supernovae are believed to be influenced by the universes. The eventual supernova of Betelgeuse will not only be a spectacular astronomical event, but also a stepping stone for future cosmic exploration. The data gathered from this explosion will enhance how we study other stars, especially as we venture further into space with missions to different planets and stars. Understanding the life cycles of stars and the properties of supernovae is critical as humanity hopes to extend its presence in the nearby solar system and beyond. Furthermore, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are essential for spreading the components required for life, such as carbon and oxygen, across the universe. By studying Betelgeuse's blast, researchers can better understand how the building blocks of life could spread to other planetary systems and potentially spark life elsewhere in the cosmos. The looming blast of Betelgeuse is set to be one of the most significant astronomical events in recent memory. Its cosmic explosion will provide a wealth of scientific knowledge, improve our understanding of the universe, and undoubtedly captivate people around the world. The death of this massive star will mark the end of one of the most prominent stars in the night sky, but it will also represent the ongoing cycle of creation and destruction that governs the universe. It reminds us that from death, new stars, planets, and even life itself can emerge. As we prepare for this monumental event, the world will eagerly watch the night sky, awaiting the moment when one of the universe's